Now in this session we are going to solve some of the problems on torsion by using for the torque transmitted the derived formulae such as torque transmitted by solid circular shaft and the torque transmitted by hollow circular shafts, and the weight ratios we are going to solve in this session with more problems. Let us start with the model. Here a solid circular shaft and a hollow circular shaft whose inside diameter is 3 by 4th of a outside diameter, 3 by 4th of a outside diameter. And these shafts are having the same material and the same length and are required to transmit a given torque. That means same torque it is. Required to transmit a given torque. Again here we have to compare the weights of these two shafts. What is the weight of solid shaft and weight of hollow shaft ratio? And if the maximum shear stress developed in the two shafts are equal. The maximum shear stress developed in the two shafts here, both are equal. The maximum shear stress developed. So a very important model it is for both engineering services point of view and also semester and examinations point of view and the semester examinations point of view. Now here let us begin. The given data is here. Di hollow shaft of inner diameter is the hollow shaft. Di equal to 3 by 4 times the diameter of the outside. That is Di equal to 3 by 4 times D naught, that is 0.75 D naught. And let us assume some of the parameters where L, capital level L is for length of the both shafts are equal, and the torque transmitted by each shaft, that is equal torque, and tau is the maximum shear stress developed in each shaft at the outer surface. The maximum shear stress are equal, where capital D is the diameter of solid shaft. There is no suffixes Di and D naught. That's why here D means is the diameter of the solid shaft. And Ws is the weight of solid shaft. Ws equal to weight of solid shaft. And Wh is the weight of hollow shaft. Now let us begin. We want weight ratio. We have to substitute first. How to start? Take a torque of a solid shaft, that is maximum torque transmitted by a solid shaft, that is tau equal to pi by 16 times tau d cube. Now that is for pi d cube, yes. Now for hollow circular shaft, here it is T equal to pi by 16 times tau d naught power 4 minus di power 4 by d naught. In this, the given here, di equal to 0.75 times D naught. Substitute in the place of Di with the value of 0.75 times D naught. That is 0.75 times D naught power 4. Simplify it. After simplification, the torque is, we got the formula here, it is pi by 16 times tau D naught cube 0.6836. Now the torque transmitted by solid shaft is equal to the torque transmitted by hollow shaft. After equate 1 and 2. The equate 1 and 2 pi by 16 times tau d cube. This is the D is the diameter of solid circular shaft. And equate 2, equation number 2, that is pi by 16 times tau T naught cube 0.6836. From this we got to know the relation between the outer diameter of hollow shaft and the diameter of the solid shaft. That's D equal to 0.8809 D naught, capital D, where D is what? Diameter of solid shaft, solid circular shaft, where D naught is the diameter of outer diameter, or DO is the outer diameter of hollow circular shaft. Alright. So D is the diameter of solid circular shaft. DO is the outer diameter of hollow circular shaft. That relation we got it by equating the same torques. And what to do? Then consider the weight ratios. What is the weight ratios? weight of solid shaft equal to weight density, that is rho g times volume of solid shaft. Rho g times volume of solid shaft means area into length, pi d square by 4 into L, doubles Ws. Next, weight of hollow circular shaft. Weight of hollow circular shaft, WH equal to rho g times volume of hollow shaft. Rho g times, what is the volume here? Area times length. What is the area of hollow circular shaft? Pi by 4 times dO square minus di square times L here, hollow shaft. That is area times length. This is volume. Now substitute here rho g times pi d naught square minus di square. What is the di here? 0.75 d naught. Here 0.75 d naught. And simplify it. We'll get the value in terms of d naught square. That is pi by rho g times pi by 4 d naught square into 1 minus 0.5625 L. So 1 minus 0.5625, that is 0.4375. This is WH. That is rho g times pi by 4 d naught square into 0.4375 times L. Which is the weight of the hollow solid circular shaft. Is the weight of hollow circular shaft. So we want the ratio of solid to hollow, that is Ws by WH. That means equation 4 by equation 5. That is equation 4 by equation 5. Substitute here weight of solid shaft and weight of hollow shaft. Rho g get cancelled. Pi by 4, both in numerator and denominator. L. Now what is the complete parameters? D square by d naught square times 4375. Now that is Ws by WH. We know the relation of D. What is the D value? Diameter of hollow circular shaft in terms of outer diameter of solid circular shaft. Capital D is the diameter of solid circular shaft. That value know in terms of outer diameter of the hollow circular shaft. That is 0.8809 d naught. Substitute here D value. Then d naught square cancel 0.8809 whole square. That becomes 0.776 by 0.4375. Then finally Ws by WH equal to 1.7737. Okay, 1.7737. That means weight of solid shaft is 1.7737 times more than hollow shaft. So that's why in the outside in practical, the solid shaft is having more weight in comparison to hollow shafts. Okay, next problem. Okay, consider here the next problem here. Hollow circular shaft 20 millimeters thick. Here this problem is related to the power transmission. Okay, and this is a problem also very important. All problems are important. The models are so important. You can see it while solving the problem. And it transmits a 30 kilowatts power at what speed? 200 rpm. Determine the external diameter of the shaft. Determine what is the external diameter of the shaft. Yes, that means D naught we want. And if the shear strain due to the torsion is not to exceed at 0.00086, take modulus of rigidity is 0.8 times 10 power 5 Newton per square millimeters. Modulus of rigidity, that is 0.8 into 10 power 5, that is Newton per square millimeter. Shear strain 0.0086, where N is 200 rpm. Power transmitted P equal to 300 kilowatts, convert into watts, that is 300,000 watts. T is the 20 millimeter. Now D is the external diameter of the shaft and dA is the internal diameter of the shaft. The outer diameter of the DO equal to DI plus 2T, 2 times thickness. That's what given, 20 millimeters thickness. 20 millimeters thickness means inner diameter is 20 and 20. That means 40 millimeters less, my negative of what? The outer diameter. So that's why here the outer diameter equal to inner diameter plus sum of 2 times thickness. How it comes here? Let us see. This is the thickness here, one thickness, and another thickness is here. Okay. So T plus T, 2T plus this is Di. Then it becomes D naught. D naught equal to Di plus 2 times thickness. Top thickness, bottom thickness. So that total thickness is 2 times T. Di plus 2T. Or Di equal to D naught minus 2T. What is the D naught minus 2T? T is the 20 millimeters, 2 times T, 2 times 20, so that 40. Di equal to D naught minus 40. What to be found here? Determine the external diameter DO we required of the shaft. So the power given here, the value, the data based on the data power transmit, that P equal to 2 pi nt by 60. What is 2 pi n? 200 millimeters power P, 300 watts, that is 300,000 watts. 2 pi n, 200 times T by 60. So the torque value here obtained here, that is the torque T equal to 300,000 times 60 by 2 pi times 200. That is 143 to 3.9 Newton meter. So that is Newton meter to be converted in Newton millimeters. That is 143,23900 Newton millimeter. Now also we know that C equal to, what is the modulus of rigidity? The modulus of rigidity equal to shear stress by shear strain. The C value given, the modulus of shear modulus, yes, modulus of rigidity 0.8 times 10 power 5. C equal to 0.8 times 10 power 5 by shear stress by shear strain. What is the shear strain? 0.0086. That shear stress equal to 0.8 times 10 power 5 times 0.0086. Then after simply calculating, the value is observed as 68.8 Newton per millimeter square. Newton per square millimeter. Yeah, we want here, objective is outer diameter. Let us begin. Now hollow circular shaft, we need to consider it. For hollow circular shaft, the derived formula for hollow circular shaft is capital T equal to pi by 16 times tau d naught power 4 minus di power 4 by d naught. Now capital T, we got it here, hollow circular, that is, what is the capital T? That is 143,23900 Newton millimeter. Substitute here, pi by 16 and tau we know 68.8. D naught power 4 minus di power 4 by d naught. Now make it simplification. The value will come, it has 14323900 times 16 d naught by pi times 68.6 d naught power 4 minus di power 4. So further, after this d naught power 4 and d minus di power 4 is converted as a square minus b square. A square minus b square means a plus b into a minus b. That's d naught square whole square minus di square whole square, do square. This is a square minus b square. That means do square plus da square and do square minus da square. This is what we got. Now substituting the value of di from equation 1. What is the equation 1? Here it is. The equation 1, we got it. This is di equal to d naught minus 40. Substitute wherever di is there, that is d naught minus 40, and simplify it. Now here, very carefully you have to do. Di equal to d naught minus 40. This is the value. Now equation 1060,334.6 d naught, yes, equal to d naught square, do square plus, what is the di means? Di is do minus 40. Substitute here, do minus 40 square. This portion is over. Next, d naught do square minus di. What is the di? Do minus 40. Substitute. Simplification. Now, again, do square plus this a minus b whole square. What is the a minus b? A square plus b square minus 2ab. That is do square plus b square, 40 square, that is 1600 minus 2 times ab, 2 times 40, 80 d naught, 80 do. Similarly, further this equation also DO square minus, this is, yes, A minus B, again simplification. Then after simplification, finally we got this value, that is 160 times DO square minus 40 times DO plus 800 times DO minus 20. Now further simplification, that is 1060,334.6 DO by 160 equal to DO square minus 40 times DO plus 800. Again you simplify it, D naught and D square, DO minus 20. Alright, cool, you will do. So this cancellation comes 6627 DO equal to DO into DO square, that is DO cube, DO times minus 40 DO, that is negative 40 DO square, yes, negative 40 DO square. This term we got plus 800 DO, this terms with DO. Negative 20 if we consider, minus negative of 20 times DO square, yes, this term. Next, negative 20 and negative 40, what happens? That is positive. That means 440 times 20 is, that is 800. Minus into minus, that is negative, positive. Positive, that is 800 DO. Next, negative minus 20 times plus positive 800. That means negative 800 times 2, that is 16,000 negative. Okay, total how many? That is with this 3, total 6. 1, 2, 3, 4, 6 terms. Now simplify it further. 6627 DO equal to DO cube minus, here it is negative 20 DO square and negative 40 DO square, that is negative summation, that is negative of 60 DO square, these two terms. Next, positive 800 times DO, that is 1600 DO minus 16,000. Okay. Now take the left hand term to the right hand side and get subtraction from 1600, subtractant from 1600, this 6627. That is DO cube minus 60 DO square plus 1600 DO minus 667 DO minus 16,000 equal to 0. From these two terms, then what will happen? DO cube minus 60 DO square, then it is negative of 5027 DO minus 16,000. This equation is the cubic polynomial, how to find out DO value. So the method is that trial and error method. Okay, so let's DO, how to find out, let DO equally how to consider, somewhere else you have to begin. So how to start? By practice it will come. You start randomly at 50 millimeters or at 60 millimeters, like there is a trial and error. Let DO equal to 100 millimeter. If you substitute DO value here, the sum should be equal to 0 or closer to 0. That's what we have to do it. Now here, after substituting this value DO in LHS here, then what will happen here? DO 100 cube minus 60 times 100 square minus 5027 times 100 minus 16,000. The value after simplifying got it as negative value, that is negative of 118700. It's a huge amount. Now let's go for again trial 110 millimeters. Substitute in the place of DO on 110, that is a 110 cube minus 60 times 110 square minus 5027 times 110 minus 16,000. We are substituting in this equation. Okay, we considering DO equal to, then that after substituting DO value of 110, observe here it is positive again, that is 36030. That means the value of DO will be in between 100 and 110. Okay. Again 100 and 110, consider 105 or 106, 107. Okay. Now finally that we consider it as 108. You consider that 108 means it comes as again very the gap that is closer here, 1194, it is so big value, but it's closer. So then after that, again 1190, then what to do? 107.5 millimeters if we consider it. So that DO becomes the outside diameter, comes more closer value to the more closer to zero value. That's why that is 107.5 millimeters is considered as the outer diameter of the shaft. That is DO is 107.5. So this value, this is trial and whenever cubic polynomial comes, you have to go for trial and error method. If it is algebraic equation, quadratic equation, suppose ax square plus bx plus c equal to 0. What is the value of the x? The x equal to minus b plus or minus under square root of b square minus 4ac by 2a. From this we get it directly roots if it is quadratic. Whereas cubic polynomial, you have to go for trial and error method. That is the thumb rule for calculating the roots, the values. So this is next problem. We go for it. The next problem here it is a hollow circular shaft. A hollow shaft of external diameter is 120 millimeters and it transmits how much power? 300 kilowatts power at 200 rpm, 200 revolutions per minute. Determine the maximum internal diameter. We want maximum internal diameter if the maximum shear stress in the shaft is not to exceed 60 Newton per square millimeter. That is the shear stress. 60 N 200 300 kilowatts, that is 300,000 watts. D naught 120 millimeters. Okay, D naught is 120 millimeters, the external diameter. And we have to find out DI, which formula we have to use. Okay, for hollow circular shaft. Okay, my understanding here it is, let us begin with the 2 pi and T by 60. Power we know, in that T becomes, yes, the T becomes hollow circular torque, hollow circular. Now, calculate torque T, that is power P equal to 2 pi N T by 60. P is 300,000, 2 pi N, 200 rpm, T by 60. From the torque T calculate. The torque T is 1432.3.9 Newton meters. Now, that is converted into Newton millimeters, that 1432.3.9 times 1000. That 14323,900 Newton millimeters. We know for that the maximum torque for hollow circular shaft T equal to pi by 16 times tau D naught power 4 minus Di power 4 by D naught. Now T, what is the torque value here? Pi by, that is 14323,900 equal to pi by 16 times tau 60. D naught 120 power 4 Di power 4 by D naught 120. From this we get the obtain the value if we calculate as Di value. The inner diameter of the shaft, that is 88.5 millimeters. Alright. The inner diameter of the shaft is 88.5 millimeters. That is what here it is. Now here, suppose if they ask you in terms of outer diameter, they have given inner diameter. If you want to calculate the outer diameter for the same problem, suppose if you substitute 88.5 millimeters in the problem, that is here, dA is the internal diameter. In some of the problems, they will give you what is inner diameter value they will provide, and we have to find out the outer diameters. So in those cases, how to start the problem? So for the given same problem, but we consider it inner diameter is 88.5 millimeters, but we want outer diameter, where the speed n equal to 200 rpms, 200 rpm, and what is the power P equal to 300,000 or 300,000 watts. Okay, 2 pi n t by 60. Next, and one more thing, yes, just the data was given. And one more thing, yeah, tau. The tau equal to value of the tau is 60 Newton per square millimeter. So how to start? How to find out the outer diameter of the shaft? Let us begin with, if we calculate torque T equal to power P equal to 2 pi nt by 60. Power P equal to 2 pi nt by 60. Okay, and here 2 pi times, what is the n value here? 200 revolutions, capital T unknown, by 60. But from this we know the power. What is the power P equal to? The power P is 300,000 watts. Okay, let us begin here. Power P equal to 2 pi n. Power P is 300,000. From that value the torque comes. The torque value becomes 60 times 300,000 by 2 pi into 200. The torque value comes. For a hollow circular shaft, the shaft is the hollow shaft, so that torque T equal to pi by 16 times tau d naught power 4 minus di power 4 by d naught. Now we know di value, okay, and we know the torque which is obtained here. Tau we know 60 Newton per square millimeter. Substitute value of the di 88.5 millimeters, and we have to calculate d naught value. The d naught will come out after substitution and obtaining the value. D naught will come as 120 millimeters has to come. So the difference between a d naught and a di is how much? D naught. The difference between d naught and di, then that yields to thickness. That yields to where? How to find out the thickness of shell? Thickness of the, what is the thickness if they ask? What is the thickness zone? This zone T. So this is a d naught and it is a di. Alright. So d naught minus di by 2 gives the thickness of the shell, thickness of the hollow, whatever thickness of the shell. Okay, now d naught means 120, di is 88.5, then it becomes 0.5, that it becomes 28, 88 minus 9, this 0.5 is 89, 89 plus 1, that is 1, 11, 31.5. Okay. Now that by 2 gives 31.5 by 2 gives the thickness, that is the thickness of the shell. So in this manner we have to find out various, the diameter, what is the hollow circular, what is the outside diameter and inner diameters of the shafts of the hollow circular shaft. Here very important thing is that we solved here, we considered the torsion or derived formula of a torque, derived formula at the maximum torque of a solid circular, of a circular cross section, we derived, that is, for a solid circular shaft, maximum torque equal to pi by 16 times tau d cube. For a hollow circular shaft, torque T equal to pi by 16 times tau d naught power 4 minus di power 4 by d naught. Okay. These two are derived for what? Circular cross section, but not a square cross section. Okay, but not square or other than circular cross section. These two are problems are meant for only circular cross sections. Very important, we have to notify it. So further, circular cross section, what is the tau in this case? Generally people call it as the shear stress, but here we should be specific. Here the tau is the maximum shear stress at the outer surface of the shaft, at the outer surface, in spite of whether it may be solid circular or hollow circular. And here in the case of the formula 1, equation 1, capital D is the diameter of the circular cross section, and in the case of the equation 2, DO is the outer diameter, DI is inner diameter, and these are what type of torques? Maximum torques, because it is the shear stress, maximum shear stress is involved, that's why it's a maximum torque is obtained. And also we found that weight of the solid to weight of the hollow. What is the ratio of the weight of solid circular shafts and weight of hollow circular shafts? The weight of solid circular shaft is always greater than the weight of hollow circular shaft, provided the same torque, same material, that means modulus of rigidity is same length. Okay, for that cases the WS is greater than WH. That's why weight of solid is always greater than the weight of hollow circular shafts. Okay, this is what we calculated here, and we solved very important models in this session. Let us glance. Yes. The solid circular shaft we considered here are ratios. We have to compare the weights and the maximum shear stress calculated in the model 1. That's a very important problem. So next, there are two problems we solved, but one problem is obtained directly. What is the diameter of the shaft? But another problem we have calculated by using which method? Trial and error method. So the trial and error method, how to calculate it? We have to go for it at some diameters, and that output should be, how can we justify this outer diameter is exact right value? The sum should be equal to 0. Okay, the sum of algebraic sum should be equal to 0. After substitution, the RHS should come closer to 0. If it comes 0, that exactly the trial value is exactly correct. But in the trial and error, we have to keep on. So after substitution, how to make it this in this trial and error method? What to do? We have to go for start with some value. Then we can know the limitation. In relation to the coming out of the value, we have to go for it. It is negative means closer to 0, or positive means what to do next? 110 millimeter becomes a positive. So 11,8700, that is 1,18,700 value to 3,6030. That means it is in between negative and positive. Then we got the limit here between 100 to 110. So if you go for it 101, 102 like that, it takes lot of time. What to do? Go for directly jump again 105, D not equal to. Then you can know. Still, it's the positive should be reduced closer to 0. Then you go for it again. Like that, we have to go for the trial and error methods. We have to substitute this trial and error method, trial and error values, and finally we have to comes to conclusion what is the value of the outer diameter of the shaft. All right, and also we solved one more problem is that power transmission relation and calculating the outer diameter of the shaft. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.